So in this lecture, we're going to talk a bit about solving applications of right triangles. Because now that we have this idea of sine, cosine, and tangent, we can actually do a lot of things with them to find distances, find angles, all sorts of stuff like that. As long as we're with acute angles right now, we can do all of that. So the first thing we're going to talk about is this idea of solving a triangle. Whoa, settle down there, pen. All right, solving a triangle. So what does that mean to solve a triangle? And it's really just something to help you practice, like, eventually we're going to want just like maybe one angle or one distance or one length, but right now we just are going to practice kind of finding everything just to get the idea of using these functions. So solving a triangle, what that means is you want to find or determine the length of all sides and the measure of all the angles. So we'll do this eventually, not just for, I can't write and talk. You think I'd be better about that? Measures of all angles. Maybe measure, I don't know, whatever. I'm not an English teacher. Eventually we'll do this for any triangle. Right now we're just going to worry about a right triangle, right? Because that's how we know how to do it for right now. It's very exciting. Eventually we'll do it for more. But let's kind of start off maybe a little easy here. So my first example, we're just going to solve this triangle. So I have a right triangle. Again, pretend that this is a triangle, right? Sorry, my lines aren't really lines. And let's say that I know maybe the hypotenuse of this triangle maybe is 7. Whatever units you want to throw on that. And let's say that this here is 30 degrees. Okay, so we'll actually be able to solve this triangle and get the exact answer. Some notation. So when we have a triangle, the right angle is usually always C, and then we have, A and B usually. You don't have to use A, B, and C. You can use like E, F, and D. I'm just going to use A, B, and C because I'm lazy, but you'll see it in other ways too. Okay, so there are my angles. Angles are usually represented with capital letters, and then the sides, the length of the sides are going to be lowercase letters that are opposite of the angle. So the side opposite of A is determined to be little a, we'll call that little a. The side opposite of the angle B is little b, and then the side opposite of angle C is just lowercase c. So if I want to solve this triangle, what I need to find is I need to find the length of A, B, and C, and I need to find the measure of angles A, B, and capital A, B, and C. So right away, if I want to, and I can just kind of write that all over here, what is angle A going to be? B, C, and then little a, little b, and little c. Okay, so right away I can fill some of this in because I know that B is 30 degrees. Obviously I know that C is 90 degrees. That's always going to be true in this right triangle. And then if I think about A I can actually get quite easily by just taking 90 minus 30 or taking 180 minus 90 minus 30. And we know that that other angle then is going to be 60, right? So that was pretty easy. Finding those missing angles are pretty easy when you're given one of the other angles. So now I just need to find the sides. So I know that the side C is 7, and now I just need to figure out what is this A and B. And what I want to use, of course, we have this new, these new like toys to play with, right? We have sine, cosine, tangent, cosecant, secant, and cotangent that we want to use because we haven't used them before. So what I want to do is, it doesn't actually matter which one you want to do. I usually just go alphabetically, but of course it doesn't actually matter. But if I want to find little a, okay, let's figure out how I could relate little a. I need to relate little a, right, somehow to the other stuff in this triangle. Well, what do I know? I know that C is 7. So if you notice, I have the hypotenuse. I can choose to either use 30 or 60. I'm just going to use 60. It doesn't really matter. So how can I relate, if I choose 60 degrees, how can I relate 60 degrees with the side A and the side C? Well, if you look at the 60 degrees, A is opposite of 60, and then C is my hypotenuse. So which trig function is opposite over hypotenuse? That would be sine. So I know that the sine of 60 is equal to opposite, which is A, all over hypotenuse, which is 7, right? And now I have this nice kind of equation that I can solve for my unknown. So what do I want to solve for? I want to solve for a. So I'm going to multiply both sides by 7, obviously, to get rid of that fraction. Put that what I do to one side, thou shalt do to the other. So what do I know a is? A is going to be 7 times the sine of 60. If I want the exact for that, you guys know, right? Because you're going to start memorizing these, that the sine of 60 is root 3 over 2. So for a, I can put 7 root 3 over 2, or I can get a decimal approximation of it, which would be, about 3.03. So approximately 3.03. Now, what could you do to find b? Well, from here you can do a couple of things. You could do the Pythagorean theorem, right? You could take the a squared plus b squared equals c squared. That's a valid way to do it, especially if you're going to just find the approximate answers. You could do it that way. I would recommend, though, if you're going to do it that way, go out a little further with this 3.03. I would go out quite a few decimal places if you're going to use that approximate answer to find b. Or what I like to do is I just keep like using trig, and then I know I'm going to get kind of the correct, well, the other way's correct, but I'm going to get a more precise answer, accurate answer, I guess you could say. If I want to find b now, right, look at b is the opposite of 30, correct? Correct. So what do I know then? That the sine of 30 degrees, right, is going to be opposite, which is b, over adjacent, which is c, or excuse me, opposite over hypotenuse. I'm talking about multiply both sides by 7 again, and I get 7 times the sine of 30 equals b. I know that the sine of 30 is 1/2. So what does b equal? 7/2. And that's your exact answer. Also, you could put 3.5. That would be your, that'd be exact as well. Again, that number might be a little bit off if you're going to use that 3.03 with the Pythagorean identity, or Pythagorean theorem, which is fine. You can use the Pythagorean theorem, but that worked out pretty nicely to just go ahead and use trigonometry to do it, because why wouldn't you want to use trigonometry to do it? Oh, sorry about that. That was from a different lecture. Ooh, I did not clean up. Okay, let's do another example. So let's solve another triangle. That might be kind of interesting. So maybe it looks a little different. Oh, those are pretty good lines, guys. Wow, look at that. It's not exactly vertical, but whatever. I'm going to just use A, B, and C again. Okay, and here's what we're going to know about, and this is, by the way, not really to scale, so sorry about that. Let's say that this is 126, and then let's say that this guy right here is 67.3 degrees. Okay, so again, what do I want to find? I want to find A. To solve the triangle, I need to be able to state the measure of all the angles and the lengths of the sides. Okay, so this will be pretty easy. B I know is 67.3 degrees. Obviously C is 90 degrees. And I could probably take 90 and subtract 67.3, but I don't trust myself to do that. So we get 22.7 degrees. I swear the higher I got in math, the worse my arithmetic skills got. All right, so I'm done with that's pretty nice. This is 22.7 degrees here. I'm done with the angles of the triangle. Now I'm ready to just do the sides. So what do I need to find? I know I'm going to need little a here. I'm going to need little c here. And really you can use, again, this is all going to be, everyone's going to do this probably a little bit differently, depending on, what trig function is your favorite, what you're most comfortable with. What I wouldn't want to use is any trig function that involves just a and c, obviously, because that doesn't give me enough information. So I want to use one of the trig functions that's going to involve 126. And one that I might do that would make this pretty easy is if I can leave that 126 in the denominator, then my known or my unknown is going to be in the numerator. That's going to be an advantage for me to have my unknown in the numerator, because then I don't have to like flip sides or anything like that. So I'm going to go ahead and find A, and we're going to, with C we might have to do it, and that's okay. But I'm going to find A, and if I want A to stay in the numerator, if I want it to be basically a over 126, right? That's kind of my goal. What would that be then? That would be opposite over adjacent if I was using the 22.7. I'm running out of room, of course. Okay, so this is going to be, if I want to use that fact that a over 126, that means that the tangent of 22.7 degrees is equal to a over 126. And in this case, we're just going to have to get an approximate answer. I don't know an exact value for the tangent of 22.7, but I'm going to multiply both sides by 126. So I get the tangent of 22.7 degrees equals a, plug this into my calculator. Oh no, not 207, 27. 126. All right, and so what do we get for a? 52.71. If I'm going to, you'll just have to see what my math lab wants, what they want you to round it to. 52.71 sounds good to me. 52.71. Does that kind of make sense? Well, yeah, I mean, look at side B is 126, so I guess it would kind of make sense that it's a bigger number, especially because you know, it's the side opposite the smallest angle, so it's going to be smaller, you know, than 126, of course. Also, when I go to find C, C should be larger than 126 and the 52.71 because C is the largest angle there. So if I want to find C, let's talk about how to find C. Now, Pythagorean theorem, of course. So if we wanted to find C without doing trig, which is silly, I don't know why you would ever do that without doing trig. But if I wanted to find C, right, I could take the 126 squared plus, and then I'm not going to use 52.71. I would round this out a little bit. I would do 52.70694 maybe squared is going to equal C squared, right? Or I just have it in my calculator. I might just square that as is. Then I'm going to add it to 126 squared. And now I'm going to square root this, and let's see what we get. So if I square root it, I get that C is 136.57972, blah, 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 blah. So let's just round that to 58. So that's what the Pythagorean theorem shows me. If I wanted to use the Pythagorean theorem, valid way to do it, but please be careful. Notice how I went out a little further with my decimals than I did right here, and I'll be looking for that in your work. So let's put 136, and then let's just talk about if we had decided to use the cool way, which would have been using trigonometry, right, to find C. And I just want to kind of show you a different way that we could have done that. So if I know, let's look at C here. If I have the 126 and the C, it doesn't really matter what I do here, but let's just use the 67.3. So if you notice, I know that the sine of 67.3, right, is equal to what? 126 all over C. Now to solve this, basically what I like to think of doing is just I'm going to multiply both sides by C, or you could flip both sides, that'd be fine. And then you have a cosecant involved, but you don't have a cosecant button on your calculator. So one way that I think is super easy is just think about, and you don't have to show that step, but if I multiply both sides by C, then I get C times the sine of 67.3. So then just divide by that. Remember, the sine of 67.3 is just a number. So if I plug this into my calculator, and I'm using my phone, which I should not be using, right? I should be using a calculator, but I'm recording this lecture for you at home, and I did not bring my calculator home with me. So let me do this really quick and hope we get something close. Yeah, so what do I get when I use the trig? I get C equals 136. Oh, I get the same thing, 0.5797265. So very, very, very close. And why are they so close? Because I did round this number out, right? So you can see either way, I just like doing the trig better, but either way we can solve these right triangles, okay, by just using our trig values. Let's look at one more maybe where we're not given, say that we're not given an angle. So let me clear this out. And let's try another one. So example, and I'm just gonna, instead of actually drawing the triangle for you, sometimes you'll see that you're just given like the A, B, and C. So let's solve the triangle if we know that B equals 1.86 and C equals 4.02. So there, we're just given this. I also just want to point out here that I want you to use, if some of you have had trigonometry before, you might know other laws, like you might know the law of sines or the law of cosines. I don't want you using those right now. I want you to focus on using sine, cosine, and tangent, right? Those initial trig functions. I want you to use those to do your work on these. We really want to get those, we want to be comfortable with those and use those. So in this case, if I'm just given that B is 1.86 and C is 4.02, I could, I can find A right away by using the Pythagorean identity or theorem, and I would do that. And I could even find other things by just kind of thinking about it, but I am going to just draw a quick triangle. It's not going to be to scale, but for me, it helps me kind of see what is going on. And so what do I know? I know that little c is 4.02, so that means that's the hypotenuse. I know that the side opposite of angle B is 1.86. Okay, and that's all I know. So we have a lot of things to find. This is going to be great. So A, B, and C, obviously C in this case is 90 degrees. And then if I want to find little a, little b, and little c, this is 1.86, and this is 4.02. So right away I can find little a. I'm going to find little a just by doing the Pythagorean theorem. That's pretty easy to do because we're given kind of these exact values. So 1.86 squared plus a squared. Whoops, I should have done probably a squared plus b squared, but that's okay. You know what? Addition's commutative. It doesn't care what order you put it in. That's the great thing about addition. It's pretty laid back. All right, so I'm going to take that 4.02. I'm going to square that sucker. I'm going to subtract the 1.86 squared, and then I get about like 12.7008, and now I'm going to square root it to actually find a. This number better be less than 4, right? And it should be around these numbers, right? If you get like 17, right, that's probably wrong. Or even if you get like 0.0002, that doesn't really make sense either. Because these two are rounded to the nearest hundredth, I'm going to go ahead and do that with this one. So this is 3.56, okay? All right, and now we're on to find some of the other angles. So when I go to find the other angles, one thing I think I'm going to just, I don't think I'm going to, I'm going to just try and stick with the values that I was given. I sure could use this a, but realize I had to do some rounding when I found a. So when I have to do rounding, when I use that number more in calculations, then any error that I have in that rounding is just going to kind of be is rolled up and kind of exasperated when I'm using that, right? So if I want to use the numbers that I know are exact numbers and are my true numbers without any estimation or rounding. So I want to use B and C. So if I look at B and C, now I always just kind of gravitate toward using sine. And so if I'm at B here, what I mean by sine, if I look at 1.86 and 4.02, 1.86 is the opposite of B, and then this is obviously my hypotenuse. So what do I know? I know then if I want to find angle B, right, what do I know is opposite over hypotenuse when it comes to angle B? That is the sine. So the sine of B is 1.86 all over 4.02. Remember, there's more than one way to do this, right, people? What's the other thing I could have done if I really wanted to use A? I could have also said, right, and maybe I can just find both of these at the same time. I could have said that the cosine of A then, right, is adjacent over hypotenuse. And I'll actually use that to find A. Why not? Let's do this at the same time here. I'm excited. All right, so how do I do this? Remember at the end of the last lecture, to find an angle, I'm going an acute angle. We don't know yet that the inverse functions exist, which kind of make me mad about this yearbook, but I'm seriously over it. Can't you tell I'm over it? I'm really, really over it. So I'm going to put that 1.86 divided by 4.02 in my calculator, take the inverse sine of it, making sure I'm in degrees, and I get 27.56 degrees. Okay, so this here 27.56 degrees. Sorry about that, it's a little off with the color. Okay, now how do I find A? A really easy way to find A is to just take 90 and subtract. That's what I would have done, the 27.56. Again, that's going to give me a bit of a rounding error, but we get 62.44 degrees here. Now, I mean, we were having some fun over here, right, with this cosine. Let's see if that kind of matches up with, if I took that 90, if I did the cosine inverse of the 1.86. Remember, these are going to be, this makes sense here, right? Because these are cofunctions. So 1.86 divided by 4.02. And then if you want to know on your phone, if you have an iPhone, if you turn it to the side, it gives you that scientific calculator a little bit. Press the second button and you'll see that the inverse trig functions pop up. It's pretty great. So yeah, look at that. If I round to 2 decimal places, we get 62.44, and all is well, because that all works out. Isn't that great? So solving right triangles, they're pretty easy to do. And what might be more interesting is maybe doing some application problems, which I think you're gonna really, really like. So let's look at how solving a right triangle, or solving a triangle, maybe not the entire thing, but using these trig to do some application problems. So I'm just going to write it down and then you'll just see it. Well, before we get there really quick, let's talk really quick about something called angle of elevation and angle of depression. So angle of elevation is basically the angle. So let's just define these. We're going to need these. We'll do some other ones that don't involve angle of elevation or depression. But let's write these down right now. And then, wow, sorry, that E looks really weird. But this is angle of elevation is the angle between the horizontal. So, you know, the horizontal is just that horizontal line, the 180-degree line, right? Between the horizontal and a line of sight above the horizontal. So let me draw you a picture. You're going to love this. So, for instance, my daughter Anna, she's really happy. I don't know why her nose looks like that. She always wears a ponytail and she loves the outdoors. Wow, she would be so happy with what I've drawn here. She loves the outdoors. So let's say, and she loves animals. Let's say there's an animal on the tree here, I don't know, and it's up here. I need to stop. Stop, Sarah, stop. Here's the animal. So here's the angle of elevation. So the horizontal would be if she just looked straight across, right? That's the horizontal. And then when she has to put her eyes to look up, it would be that angle that she would have to look up at. So this angle right here, this angle theta, okay, that would be the angle of elevation. Whatever that angle is that she would have to look up to see the animal in the tree apparently is going to be, it's a beautiful picture. I know I missed my calling being a math teacher. I really should have been an art teacher. Same thing, angle of depression. So that's angle of elevation. Okay, angle of depression is the same thing except we're going to be looking down. So this is the angle between the horizontal, okay, and a line of sight below the horizontal. Okay, so again, we have Anna. Well, maybe it should be Eliza this time. Okay, let's make it Eliza. Eliza also wears a ponytail, though. Maybe we'll put her in pigtails, even though she doesn't let me do that anymore, because she's now 5 years old, and, you know, you can't do that anymore. So, Eliza likes bugs. Let's say that there's a bug. It's a happy bug on the ground. These are beautiful pictures. And I have my horizontal, right? So if Eliza was looking straight across, that would be the horizontal. But then if Eliza wanted to look down at a bug, okay, on the ground, which she would absolutely do, and then she would probably go try and touch the bug, much to my horror. That would be my angle of depression, okay? So it's that line of sight below the horizontal. I think these pictures right here just really helped a lot to help you understand angle of elevation and angle of depression. So let's look at kind of a simple example to start with. Okay, here is our example. I know it looks like it's super long and complicated, but it's really not. So you might want to pause the video to write it down because I'm not going to really wait for that to happen. But we have from the top of a fire tower, a forest ranger spots her partner on the ground at an angle of depression of 40 degrees. So real life, people. I will tell you, a long time ago, I mean, I know I'm not that old, but I used to be a firefighter. That's actually why I came to this area, was because I was fighting wildland fire for the BLM. So next time I see you guys, maybe I'll have to tell you some stories about that. It was very exciting. And so that's why I kind of love the fire tower ones. Okay, at an angle of depression of 40 degrees, if the tower is 45 feet tall, how far is the partner from the base of the tower to the nearest foot? So just like any word problem, you know, they have like those 5 steps of word problem, and I probably should promote these a little bit more, but you know, they're like, read the problem again, draw a picture if necessary, and then write it into a mathematical model, an equation, and then solve the model, and then check your answer and make sure that that makes sense. Ooh, sorry about that. Okay, so I'm gonna draw a picture, I'm gonna come up with an equation, I'm gonna solve the equation, I'm gonna make sure my answer makes sense, and then because you have me, you're gonna state your answer in a sentence. So fire towers, I don't know if you've ever been in a fire tower. They're really cool. There's one in the Ashley National Forest that you can actually go, and I think you can even like stay in it overnight and stuff. So you should go and do that sometime if you ever have a mind to. But they're pretty neat little towers where a person sits up here and smiles and watches for fires right out in the distance. But we're not doing fires in this case. Let's say that this person just saw her partner. Oh man, I am just such an amazing artist. Hanging out on the ground, and as one does when one is just hanging out by themselves in a fire tower with nothing else to do, one measures angles of depression. So a couple things that I know, right? I know that the angle of depression, let me make that a little bit straighter, or try to attempt to. The angle of depression from her to the foot of her partner, let's say. So we could say like to the partner's head. It'd make it a little bit more complicated, but we could do that. But let's just say to the base of the partner. We know that that angle of depression then is 40 degrees, and we know that the height of the tower is 45. So it's interesting because we're saying that the height of the tower, really are we saying from the very top of the tower or to her line of sight? So I'm being a little bit lazy here, and I'm just saying that this is 45 feet, right? 45 feet maybe from the ground to her, technically her eyeballs. So this is going to be 45. We know that the angle of depression, so which angle is it? Remember, it's the angle from the horizontal, right, to the line of sight. So this angle right here is 40. So a lot of times what I'll do is so I try to really create in the pink there, it's kind of a triangle, right? So I'm going to actually just kind of pull my triangle out over here to make sure I know what's going on. Here's what I know. I know that this is 45. I know that this angle of depression is 40 degrees. And what do I want to know? This is what I want to know right here. I want to know the distance, right, that the partner is away from the tower. So I just kind of took with my information and I wrote it over here in a triangle that's going to be easy for me to kind of see. So what do I need? Well, I want to use some sort of trig, right, to do this. But the problem is right now, I don't actually have any angles in here. But what I do know is that the horizontal with this vertical right here makes a right triangle. So I know that if I went from the horizontal all the way to the vertical, that would be 90 degrees. So if I take 90 minus 40, then I know that this right here would be 60. Okay, so they always are going to give you some sort of information there. How else could you have done this? Well, another thing you could have done is if you remember from geometry, I don't, but I'm going to now, is that if you have two parallel lines, right, which we'll assume that the ground is horizontal, and I have anything that cuts those two parallel lines at transverse line, we know that these two angles must be equal, right? These two angles are congruent. That's the other thing you could have done. So some of you are going to do this a little bit differently. Some of you will use that 60, some of you will use the 40. It's really up to you. I'm just going to use the 60 because it's right there. Also the 60, when I take opposite over adjacent, that puts my unknown, right? That puts my unknown in the numerator, which I like having my unknown. Whoa, settle down here, Sarah. I like having my unknown in the numerator because then I don't have to really mess with it. I can just multiply both sides by 45 and I'm gonna get my answer. I hope that makes sense. So I have opposite over adjacent. How did I know to use tangent? Because I know that, I know that tangent is opposite over adjacent. So I'm gonna take 60 degrees, I'm gonna take the tangent of that, and then I'm gonna multiply it by 45, right? By bringing that 45 over. So how far away is this forest ranger's partner? About 77.9 feet, but remember this said to the nearest foot. So what would my answer be to the nearest foot? 78 feet, okay? Now, because I'm the teacher, I don't have to write in a sentence, but you do. So your final answer, would say the partner is 78 feet from the base of the tower, something like that. Again, we could have done an angle of elevation. I'm not going to do it. We'll do another angle of elevation here in a minute. We could have done an angle of elevation also, like an angle of elevation problem would have been like the partner sees her angle of elevation to be 40 degrees, right, up to her partner in the tower. Okay, let's do another one. Because we're at 31 minutes, and apparently in this semester, I'm going like 40 minutes every time. So let's do another one. All right, guys, another real life situation. I don't know how many times I've been wanting to put up a zip line and really need a trig to do it. So we have a steel cable zip line is to be constructed as shown below. How long is the zip line? Okay, so a couple things here. I've given you a few dimensions. So here's what the zip line does. If you guys have been zip lining, it's a blast. Again, I'm going to draw people happy about going zip lining, right? So they start off on here, and then so on a platform, obviously that's higher than another platform. You get on the zip line and you're in a harness and everything, and I was freaked out the first time I did it, and then I absolutely loved it. And then you zip line down and you land, at some platform here where there's a professional person there waiting for you and making sure you don't, hurt yourself, which hopefully you don't. So here's some stuff we know. We know that the platform that you are going to leave from is 150 feet tall. The platform that you're going down to is just 5 feet tall. And we know that the angle right here is basically an angle of elevation, but the angle is going to be 23 feet that you go across, okay? So what I want to know is how long is the zip line. So this here is my unknown. I want to know how far I'm going to be going. So I have to construct some, and this is not to scale. Clearly 150 and 5 feet, right? That doesn't look like that's correct, but that's okay. So what I need a triangle. So what I'm going to do is I'm just going to extend this horizontal line kind of all the way over, and I need a right triangle. Notice how I'm going to have to extend that. If I tried to use this right triangle right here, this guy, that's not going to work because this guy doesn't keep going down, right? And I would have to really work hard to figure out how far it would go if that did come down, and there's an easier way to do it. So I'm just going to go ahead and draw that horizontal across, and I'm going to deal with this long triangle right here, okay? So notice I have the 23 degrees, I have that hypotenuse, which is x. Now really what I need to do is I need to figure out this distance right here. If I can find this distance right here, then I'm going to be able to use like another sign, I think, right, to do that. Well, I know if this whole distance, right, is 150, I know also that this distance here is equivalent to this distance here. So I know that this is going to be 5. So I can clearly see, obviously it's not to scale, that this height right here is 145 feet. Basically just taking that 150 and obviously subtracting the 5. So again, do you see these get pretty easy sometimes once you can figure out what your triangle is. So I actually don't need this horizontal distance at all. I want to use the 23, I want to use the x, and I want to use the 145 to figure out what I got. So if I look at 23, I'm going to do sine. So the sine of 23 degrees, right, is equal to 145 all over x. Okay, can't really get around putting that x in the denominator. You could use cosecant. Cosecant would be x over 145, but then I'm just gonna have that 1 over sine anyway. So again, in my mind, I usually don't show this step of multiplying the x, but what I do right away is I usually just say, okay, that tells me then that x is 145 over the sine of 23. I usually will go just straight to that step right there, okay? So 145 over the sine of 23 is about, I think, 371.1 feet. Okay, and I didn't tell you what to round to. That is my mistake. I should have done that for you. So that whole length there is about 371.1 feet. Okay, I think that's pretty simple. If it wanted to know like how far are the two platforms apart from each other, then I could use cosine of 23, and maybe I call this y right here. I could use cosine of 23 as y over now the 371. Or if I want to use that same, I want to use the 145, I could do tangent of 23 as 145 over y and then solve for y. Call it good. All right, you guys, I have one more to do and then I'm going to be done. I promise. I want to do this one because it's a bit of a doozy. Okay, so let me write it down. Okay, so here's our last example. You're just gonna love it. All right, so you're traveling across flat land when you notice a mountain in front of you, and of course you take out your whatever to measure elevation, and you notice that the mountain has an angle of elevation of 3.5 degrees to its peak. So from your horizontal up to the peak, right, is going to be, well, not even from your horizontal, we're just going to say from the ground, okay, up to the peak. After driving 13 miles closer, the angle of elevation is now 9 degrees. That kind of makes sense, right? You're getting closer to the mountain, so you're going to have to look up further. Approximate the height of the mountain to the nearest mile. All right, so here's what we got. So I'm going to try and draw it kind of, well, let's see here. There's our flat land. My mountain is going to be amazing. Of course, you wouldn't expect anything less from my beautiful artistic skills. And here's what's going to happen. So I'm just going to draw a vertical line here to indicate the peak of my mountain. Okay, so here, let's say this is the first time you decide to take the angle of elevation of the mountain. And so we know, right, that was 3.5 degrees. Then you drive a little bit closer. Now, this is not to scale, obviously. Drive a little bit closer, right? And then you take the angle of elevation again. And right now, I'm just going to go ahead and get rid of this side of the mountain, if you don't mind, because it doesn't really matter because we're looking at just the peak of the mountain, okay? So you take the angle of elevation again from the second spot. I need to go ahead and get the pen and not the eraser. That would be good. From the second spot, right? And you notice that the angle of elevation now is 9 degrees. So again, from the horizontal, right, to that line of sight. So notice what we have here, and I'm sorry for the shaky lines. We basically have two triangles right here. So I have this triangle right here, right? And this is a right angle. And then I also have this large triangle right here. Okay, and that's a right angle also. Anything I know about this triangle? Yeah, I do know something, right? I've driven 13 miles. So I know that from the first sighting to the second sighting, I know that this is 13 miles. All right, so what do I want to find? What I want to find is I want to find the height of this mountain. So I'm going to label that as H. You could label that as Y, whatever you want to label it as. So if you notice in this small triangle and even in the big triangle, there is something that is not known. And that something that is not known is this X right here. That is the distance when you took that second reading to the center of that mountain. So I have two triangles. So what I'm going to do is I'm going to write down what I know about these two triangles using a trig function. And then if I can figure out two equations, if I have two equations with two unknowns, I can do like substitution or elimination to figure that out. So let's look at the big triangle. Well, actually, let's look at the small triangle right here. So 9 degrees, how is 9 degrees related to H and X? Well, I know that the tangent, right, of 9 degrees is equal to opposite, which is H, all over X, right? I know that to be true. Get rid of that really quick. And then if I look at my big triangle here, if I look at the tangent of 3.5 degrees, it is also going to be opposite, which is h, but what is it going to be over? It's going to be over this entire distance here. Well, what is that entire distance there? That entire distance is x plus 13. I hope that makes sense, right? It's that whole thing together. So that's x plus 13. So look at this, you guys. I have an equation with two unknowns. So what I'm going to do is I'm just going to go ahead and solve here for h with both of them. Now I could solve for h here and then plug it in, but I actually am just going to solve both of them for h, and I'll kind of, the reason I want to do that is because it gets rid of the fraction. Not that I'm scared of fractions. I'm not scared of fractions. So what do I know? I know h is x times the tangent of 9. And if I do the same thing over here, I also know that h is equal to x plus 13 times the tangent of 3.5. That is also h. So because those two are the same, that means I can replace one with the other, right? So this h here can be just replaced in right here, and now I have an equation that I can work with. So I'm going to rewrite this. I have x plus 13 times the tangent of 3.5 is going to equal x times the tangent of 9. And we've seen this show up. We saw this stuff show up in algebra, right, where we had to solve for a variable, and maybe that variable wasn't by itself and it was being multiplied by something. So this tangent of 3.5 is just a number. So what I'm going to do, because I need to get all my x's on one side, I'm going to multiply that tangent of 3.5 through here. I would get x times the tangent, and there are different ways you can do this. This is just the way that I think is the easiest. 13 times the tangent of 3.5 equals x. I'm going to run out of room. That makes me sad. 9. And now if you notice, I have two terms with x's in them. So I'm going to take this term right here and I'm going to move it to the other side. So I get 13 times the tangent of 3.5 equals, and then notice when I move that over, I'm going to have an x and everything. So I'm going to factor that x out at the same time. I hope that makes sense. I'm being a little bit lazy here. Tangent of 3.5 times x. Oh, that's bad. Sorry, guys. Kind of got excited there. So again, what happened there? Let me rewrite that really quick up here. Remember, what do I have now? I have 13 times the tangent of 3.5. Here's what happened. 5 degrees equals x tangent of 9, right? 9 degrees minus, then I had x the tangent of 3.5. That's technically what happened. And then what did I do? I just factored out that x because there is an x with each of them. So I'm left with the tangent of 9 minus the tangent of, oh, I still am not going to have room. Well, a little bit more room is x. Okay. Now I'm going to erase some stuff so we have a little bit more room here. Now you could have solved for x. It's a little bit harder, but you could have here solved for x and then put the solution into this fraction and gotten rid of fractions and stuff. That would have been fine. So what do I get for x? I get 13 times the tangent of 3.5 all divided by, right, tangent of 9 degrees minus the tangent of 3.5 degrees. That is going to give me my x value. Okay, so that got rid of the fraction, all that good stuff. So I get, I can put this into my calculator. I get the x is about, I'm gonna round out a little bit more, 8.17834. That's what I get for x. But is that what the question asked for? And we're in miles, right? Because that 13 has units of miles on it. That's not what the question asks for, right? The question asks for you to approximate the height of the mountain. And right now the height of the mountain is my h. So what can I do then to find that x? Well, I have this relationship, right, between x and h right here. I know that h, I guess I just erased that, is equal to x times the tangent of 9 degrees. So I'm just going to take this 8.17, plug it in for that x right there. I'm going to get the height of the mountain to be approximately 1.295 miles, or it says round to the nearest mile, so approximately 1 mile high. Not a huge mountain, especially when we're used to Wyoming, right? But remember, that's just the height from basically where the road meets the base of the mountain to the top of the mountain. Really, if you want to think about it, that about 5,200 feet. I hope that makes sense. Let me know. That one is a little tricky. Look at the fun sheet I post. I do another one like that on the fun sheet. And I believe there's one on your homework like that. So make sure that one kind of makes sense. If you need any help with it, just shout. Let me know. Okay, guys. Have a great day.